Cool. Thanks everyone for joining us today. We're very honored to have Meta, PyTorch, Linux Foundation, Unsloth, HuggingFace joining us for this amazing workshop. And then this workshop is a part of the custom tracks for AgentX, AgentBeats. For some of you, I trust some of you guys are already very familiar with AgentX, AgentBeats, but for some of you guys that are not so familiar with the competition, we're very excited to share that we recently concluded phase 1 of the competition, which we have possibly over 1,300 teams and then over 3,000 individuals, spanning across many different engineering schools as well as many different tech companies joining the competition and building the either identifying the existing benchmarks or creating new benchmarks, on tags and then assessment to score agents' performance. We have very good results. We recently released the winners of phase 1. Please go to AgentBeats website to check out the winning teams, and then we will soon start phase 2. And for the custom track OpenEnv challenge sponsored by Meta, HuggingFace, and Unsloth, that custom track started in early January and it will end around end of March. And we're here very honored to have the speakers from Meta, Unsloth, and HuggingFace talk more about OpenEnv as well as the challenge, the custom track. So without further ado, let's welcome our speakers. Joe, thank you so much for joining us.
Awesome. Thanks, Linda. Welcome, everyone. I'm Joe Spizak. I'm from Meta. I'll talk about who's presenting here in a moment, but just wanted to welcome everyone to the Agentic RL and Environments Workshop. This is, I think, a major milestone, I think, in the project that we started late last year called OpenEnv in partnership with Daniel and Unsloth folks, as well as HuggingFace, so with Ben and Lewis and other folks over there. And our goal was really to build tools and build an ecosystem that democratizes the use of RL. And I think one of the biggest barriers that we saw was access to environments and environments, the fragmentation that was happening around environments. And so this ecosystem is moving super fast. It started out with just a handful of us, and now it's grown to something much crazier and much more amazing. And so, I mean, as evidenced by all of us here today, partnering with you all. And the nice thing about everything that we're doing is it's open source. And built on open source foundations, and hence we brought in PyTorch as part of this. So really excited to have everyone here. In terms of speakers today, of course myself, I'm with Meta. I lead our efforts around PyTorch at the company as well as our agentic infra. And the nice thing about us, we tend to work a lot in the open, which is really exciting. Then we also have Daniel from Unsloth. I don't think he needs any introduction. He's built the amazing Unsloth AI tools that are used by literally thousands, if not millions, of developers globally. Sanyam Bhutani, who is also with me at Meta. He also has a huge following and formerly Fast AI, and has been building a community around RL and environments with me, and which has been really cool. And then Ben Burtonshaw from HuggingFace, who is definitely more than a community education guy. He's one of the top contributors, if not the top contributor, I think, to OpenEnv at this point, committer on the project, and really has been instrumental in growing this community and building OpenEnv to be what it is today. So amazing set of speakers. We are going to dive into some things that I think you can get hands-on with really quickly. We have notebooks, we have examples. This is something that's a mysterious dark art between the power of HuggingFace and Unsloth and some of the technology in PyTorch. It's super approachable and super easy to get started with RL. So we're excited to have you all as part of this track. Quick plug for the agenda, and then for the PyTorch Foundation. So here's the agenda. After this, we'll move into Daniel and Sanyam digging into kind of zero to hero with RL environments. Like I said, there's notebooks that we have that you can then take away. They're already open source. You can spin them up on Colab. It's very easy to get started, and everything is out there for you. And then Ben will jump in and talk about the hub itself. One of the goals we had is to get the hub that we co-developed on HuggingFace to be really the center of mass for environments and allow anyone to basically build environments, deploy them, use those environments along with all of the other things that HuggingFace offers, like data sets, models, evaluations, and so they create network effects between everything. And of course, so we want that to be a central place for the community to be able to share and collaborate openly. And then we'll open it up for like the last about 10 or so minutes for any Q&A that you all have. So ask your questions on YouTube, and we'll get to those later on in the talk. A quick plug for the foundation. This is a foundation that we started now almost 3 years ago. I helped start it here at Meta. We wanted PyTorch to be, open and collaborative, and so the goal really is to create an open place that's vendor neutral, that allows developers to kind of come together. And we wanted to not just be a Meta thing. We wanted to be a global, global thing that anyone could participate in. So you can see some of the members here. And we have lots of them at different tiers. We have lots of projects in the ecosystem, including some of the most popular projects like SGLang, vLLM, Varel, and so on. And then we have hosted projects, of course, including PyTorch, vLLM, DSpeed, and Ray today, with a few more definitely coming. So with that, I'm going to pass it off to, I think, Daniel or Sanyam to share the screen.
Awesome. Thank you so much, Joe. And hey, everyone, it's a great honor to be presenting to you all. Daniel and I are going to talk about why did we create open environments and some context about reinforcement learning, followed by our integration with AgentBeats. I'll also give a little bit of context around housekeeping and how you can submit, but that's what I'm going to talk about. And then Ben will actually walk you through how you can make the submissions. Let me go ahead and share my screen and figure out which is the right screen to share. There we go. Hopefully everyone can see this in full slide mode. I see nod from Daniel, so hopefully yes. Awesome. So some competition rules. It's pretty open-ended. Please build on top of OpenEnv or our integration with AgentBeats. That is the only requirement, and we leave it open to everyone. Once you have that, please push this environment in the open, and I'll talk about why we're building this in open source. Once you have that, we'd also love to learn why you did this. So please consider writing a blog on HuggingFace. It's actually really easy and it's awesome to get started there. And Ben will walk you through how to do that. As a reminder, deadline is 31st of March. You can have as many submissions as you want. If you have questions, jump to the OpenEnv Discord. How do you get there? I can point the GitHub link, which we'll update in the description. But even if you just Google OpenEnv and go to the GitHub repo, the Discord's right there. So please join us there. Ask questions if you have. All of us hang out there. Tag me, tag any of us, and we're there to help you take part in this competition. So let me start with a little bit of context around RL and preface that as to why did we decide to open source open environments. So the goal of RL is to teach an agent from experience. Of course, we're like much ahead of that, but very simply put, with an example, let's say you're trying to teach your dog to sit down. The dog is learning from observations, and initially it's not very learned about your words. So when you say sit, maybe it barks or does something silly, and the observation it will get from you is maybe it gets a scolding. So based on its action that it chose, it'll get a negative reward from you. In this example, your dog is an agent. The observations you're giving it are either a scolding or a treat. And this is an episode of learning where at every step, there's some interaction happening. So this is the crux of reinforcement learning. And these terms have been around for a while. So for those of you, and I'm sure I don't need to educate everyone here about this, but just for the sake of completion, any RL loop has these 4 concepts, which is resetting, where you start a new episode of learning. You have an observation, which tells you what's going on in an environment. An action is decided by your agent. So in our example, it's sitting down, spinning, barking, or doing something silly. And a step is taken at every single interval of the episode of learning. So the pattern is kind of universal. Your agent will observe, act, it will get a reward, and hopefully learn. The hopefully is actually really hard, and Daniel will talk about it. It takes more than hope. But when you try to apply this to LLMs, a quick problem is obvious. I'm just referencing some open environments that are out there. But you can imagine that when you're training your LLM with something like a word class training API like TRL, or if you're running on Colab, maybe using Unsloth, you want to focus on improving your LLM and not writing plumbing code. If you try to connect different environments, it's basically different API specs that need to talk to each other. And this will block you from moving fast. So this is a pain point we're trying to solve. Where in your training loop would ideally look like this. And usually you're not hoping to teach your agent just one thing, right? You don't just want it to be better at programming, you want it to be better at many things. So in an ideal world, we want to get to a stage where you can import from any environment, and all you do in your training loop is change the first line. So you go from Android environment to, let's say, computer control environment or something like that. And you're using maybe TRL or Unsloth. Anything else in your training loop should not change. That is the goal we're trying to achieve with OpenEnv. So in an ideal picture, the RL algorithm is handled by your training API. You download your LLM and you're just changing environments which are brought in from OpenEnv. And hopefully this makes it a universal interface for you to be able to teach your model or your agent any given task. Now, to make sure that this is a success, we have defined a nice set of specifications and we have a solid set of RFCs. I'm going to only talk about a few of those, but I invite everyone to find them in our GitHub repo. If you do not agree, please roast us in the issues or send any complaints you have to us. We're doing this for you, and we're doing this because we care about making sure everyone can train their agents in the open. So we'd love your feedback, but the starting place that we've decided is let's use the same concepts that Gymnasium API has used. So step, reset, and state. And let's package that in Docker files. So once you try to scale your training beyond one GPU, it's easier to scale that with Docker. And to make sure all of this is using the same spec, you can package these under the same specification. This involves the following 5 steps that you can see on your screen, and I'm going to use an example. You do not need to memorize this. Ben will show you how easy it is. You just need to use our CLI, which will initialize a skeleton of all of these files. And then with just one command, you can push to HuggingFace up. So in reality, it's very easy to get started, but it's these 5 steps that take or that you need to take to get there. So let's look at a real example. Let's look at Connect 4 game. I've never won this game. I tried cheating and I'd always get caught. So I'll only reference what's on the screen. But let's say in the model's definition, you have to, first of all, define an action and observation class. So an observation in this case would be the board of the Connect 4 game. And of course, you'd also need to define what legal actions are allowed, the sort of limit what your LLM or your agent, maybe you're not using an LLM, can do. And then you have to keep a track, is the game finished or not? And what's the reward? So you define all of these in the model definition. And in your environment, you expose the behaviors. So when you reset the game, basically you clear the board. In this case, you just create a NumPy array. Sorry, it's not visual. It's a simple NumPy array. And honestly, most environments are really simple when you try to think about them. In a step, you're just dropping a piece in any of those columns in that NumPy array. And then finally, you'd want to package this in a fast API server. So you define that in app.py. And I've not shown it here because it's straightforward, but then you want to package this in a Docker file. So it's easy to download and easy to talk to. That's all it takes to define your environment. And once you have that, you can imagine your training loop then becomes just grab this from the Docker image and let Unsloth do the magic on top. As you scale your environments, I'd encourage everyone to just think on these patterns and spend more time thinking about what you want the behavior to be rather than the patterns, because honestly, the patterns are really straightforward, and hopefully they are after this quick intro. Now, that was a quick ramp up on OpenEnv, and I'll also do a quick walkthrough in a second. But I also want to talk about our integration with AgentBeats. And we've actually called this EnvBeats because it's an integration between OpenEnv and AgentBeats, EnvBeats. Hopefully that makes sense. Once you get past the training stage for LLMs, there's an obvious issue as well for agentic assessment, which is it's quite hard to benchmark the behavior of agents. Because you can imagine that at any given question or task, an agent will take different paths every single time. So how do we effectively assess this? And this is a task that I'm sure you all know AgentBeats has been trying to tackle with its definition of a green and a purple agent. OpenEnv is sort of simplifying the behavior of the environment in this case. So in our opinion, it's a natural synergy where all of these pieces sort of connect together. And AgentBeats then naturally can connect into open environment to bring these together. So to refresh everyone, AgentBeats has an assessor, which is a green agent. I like to remember this as the judge, and the assessee, which can take different actions. And if you think about it, most actions in real life also usually are evaluated like this. Your actions are usually evaluated by another intelligent agent, if I may. So it kind of makes sense to have agents sort of evaluate each other's behavior. And to make sure this works well out of the box, the awesome team at Berkeley has standardized this on the A2A spec. So both of these agents will use that. And to talk to open environment, they've used MCP to connect the pieces together. The great thing about this, and I'll show this in a demo, is you can also just be a human in the loop and actually inspect the outputs. So it's actually really straightforward to interpret as well. And I'll show that with a demo in a second. So once we bring these pieces together, OpenEnv becomes the standardized environment interface. This is where your actor agent or your purple agent can interact. We can then use A2A to connect these to an assessor or a judge agent. And then MCP can be used to expose environment tools throughout the runtime. In other words, you don't need to worry about installing any dependencies. All of these communications will happen over standardized tools, and you can focus on building the benchmarks or focus on building the behavior of these agents. So here's a quick overview of what the demo is about. I'm going to kick off an assessor, which will actually use an environment running on HuggingFace spaces. And then I'll be the human in the loop making an actions, which will then go to the judge agent talking to an environment running on HuggingFace. What I'm trying to show here is without installing any dependencies, without worrying about any of the nuances, we're very easily able to bring together different infra pieces and also different agents interacting in different deployments as well. So let me switch screen sharing and give a quick demo on this. So I can find the right screen to share. Sorry about that. Awesome. I'm just going to share my entire screen and go from there. So what I'm going to do is launch the MCP gateway here. It'll take a second. I'll launch the assessor agent as well in parallel. Wait for them to come online. So my gateway is up. My assessor agent is up as well. and so is my human in the loop gateway. Now I can go into a nice web UI demo. And again, what I'm trying to show you here is we have an environment running on Hugging Face Hub, and we're able to bring a judge, me as an agent, a human agent interacting with this environment deployed somewhere else without installing any dependencies. So I'm going to make sure I have the right authentication. And this is just a dummy code, but if I change this to 1, 2, 3, I become the judge. If it's 4, 5, 6, I'm the actor agent. Let me connect to this. If I go to tools, you can see the tools that I have access to as an agent are the standard open environment definitions that we just looked at. So if I go to state, if I try to take a step and send a message saying, hello, Daniel. If I send this by running the tool, you can see that I got a reward of 1.2. Now, if I lengthen my message, hopefully the judge is able to pick this up and give me a better reward or a higher reward. That's how the environment is sort of defined on Hugging Face. So you can see the reward side slightly increased. And once I'm done making all these interactions, I can, of course, close the episode as well. Now, what happened here is we brought together different agents and also an environment which is actually deployed on some server, I don't know running where on Hugging Face spaces. The cool thing about this is you can imagine in maybe a coding use case or something that's even more sophisticated, you don't have to worry about bringing all these pieces together. You can define them separately, and you can let your focus be on this piece, which is how does your agent interact with the environment. That is the challenge we've presented for you all as part of this special track in the competition. So now I'll pass it to Daniel and let him talk about how you can train your agent. This was a quick walkthrough, and if you have questions, please ask them in the chat. I'll get back to them.
Yeah, thank you, Sanyam. Yes, let me share my screen. Yes, okay. Yeah, so yeah, Sanyam had a very good intro to reinforcement learning and how you can use open environments as part of the competition. For you guys who don't know me, I'm Daniel from Unsloth. And yeah, super excited to be part of the competition, and reinforcement learning is extremely fun. It can be very confusing at the beginning, so I'll give you like a high level overview of what reinforcement learning is, and how can you do the competition much easier. So reinforcement learning is essentially you just ask a question to the language model, create a Python function to do fast matrix multiplication, right? So as an example, you just call a language model to do something like this. And then the trick is, okay, you can call the model not once, but you can call it 3 times, right? You can call it infinite times. And every single time you'll have different algorithms that it will create. All right, the first one is uses some PyTorch function. Another one uses a NumPy function. And some other function uses some, the multiply operator inside of Python, matrix multiply. All of these are automatically created by a language model. You just ask the question, I need to create a fast matrix multiplication algorithm with Python. But the difference is in reinforcement learning, we will verify if each of these implementations are correct. And so the trick is each of these implementations will get a score. For example, the first one is pretty good, right? Because it uses PyTorch, it's relatively effective. And so it gets a +10 score. The second one, it uses NumPy, so it's a little bit slower because it doesn't use the GPU, for example. So you will get a score of -5 because it's not very fast. But at least it works. And then the last one will get a score of -100. And the reason is because it adds 0.001 to the first matrix. So that's definitely not good. And so reinforcement learning, all you need to do is you call the language model many, many, many times, and then you score each of the implementations. And all of these numbers, the scoring you get to determine, right? It doesn't have to be plus 10, minus 100, minus 5. You can also do like 0 if it just fails, and 1 if it actually succeeds. So you can actually change the scale of the rewards as you like. And another way to think about it is reinforcement learning is kind of like luck is all you need, or more like patience is all you need. At the very beginning of training, the reward will always be 0. And so there's not that much signal, right? You'll get like minus 100 reward, minus 10, minus 50, something like this. Then as time goes on, reinforcement learning will learn, okay, these are the bad answers. Let's do these less. And then suddenly you will get a good answer, right? So like finally, after waiting for some time, reinforcement learning will create a good algorithm for matrix multiplication, for example. And then the trick is over time, this reward signal will keep going up. And then that's why I call it like you just need to wait as long as you like. And so like the longer you wait, the more likely reinforcement learning will win. And so one of the tricks of reinforcement learning is when you automatically generate, like for example, a fast matrix multiplication algorithm, it will assign a score of plus 10 to every single line and every single token of the entire stream. And so it's also not good sometimes. Like, for example, sometimes there might be some problematic statement inside of the reinforcement learning, generation, the thinking traces. There might be like some sort of like problem, and you still assign a score of plus 10. And so reinforcement learning does have some issues where you assign the same score to every single line. For example, a very bad output, with the plus 0.001, you assign minus 100 to every single line. But maybe it's not a good idea to assign minus 100 to every single line or every single token. Because like, for example, the multiplication operator is correct. It's just the full result is wrong, right? So like that's why we assign a minus 100 to everything. And so that's where, even if you assign minus 100 to everything, you do need to consider other things. For example, like, do we consider the formatting? Is that correct or wrong? Do we look at something called priming or warm-up? If reinforcement learning doesn't really work, how do you force it to work? So like, for example, you should add some supervised fine-tuning data set. You should add some data set at the very beginning to do fine-tuning and then do reinforcement learning. This can help reinforcement learning. How do we do, will it be too out of distribution, for example? And then maybe you'll always get negative rewards. So you need to consider extra things during reinforcement learning. And one of the reasons why we don't just want to assign minus 100 to everything is sometimes, there's also something called reward hacking. And so, for example, when you do, this is kind of like cheating. When a model generates things that actually edits the entire algorithm, right? So like our goal was to create a fast matrix multiplication algorithm, but instead the model is, editing the timer. It deletes the timer, for example, or like makes A go to 0 or B go to 0. It does some very weird things. And all of these will just be scored as one, it will only score the final answer. It won't score intermediate steps. So, these things will happen during reinforcement learning and you need to be careful. Another one's, for example, corrupting your actual computer. It might do some funny things like, deleting files from your computer. And so like reinforcement learning, when you execute code, you need to be careful of, what is actually being executed and what is actually being created. And, one of the other factors of reinforcement learning is you need to care about efficiency. When you do reinforcement learning, it can be very, very inefficient. It can be very slow and very memory hungry. And so, for example, for Unsloth, we spend a lot of time trying to optimize, reinforcement learning, trying to make it faster, trying to reduce memory usage. For example, we collaborated with, HuggingFace and the PyTorch team to make, MOE training for reinforcement learning, much, much faster. So, MOE training is now 12 times faster and uses 35% less memory. And so this actually allows you to fit, on Google Colab, which is like 16 GB of VRAM. And so like you can do, the AgentBeats competition for free on Google Colab with OpenEnv and HuggingFace and PyTorch, Unsloth. And one of the other factors of reinforcement learning is you need to make inference faster. Inference is 50% of the entire process of reinforcement learning, but it takes 90% of time. So like you need to make inference much, much faster to make reinforcement learning work. And yeah, so like we actually have free notebooks using OpenEnv, and like to show you how to play 2048, for example, on Google Colab. And this is a free notebook that you can actually access. And in the notebook, you can show you how to install Unsloth, how to install OpenEnv, and how to actually run the entire process. We'll be using GPTOSS 20 billion, so OpenAI's open source model, and essentially you can train it to create the 2048 game and play it. And yeah, there's many parts of it. I will actually share my other screen. Okay. Oh wait, I have to exit from this. Yes. So if you go to, if you search on Google, OpenEnv, you go to the GitHub page for OpenEnv. If you scroll down a bit, there's like, Google Colab notebooks, examples of how to use OpenEnv. But if you scroll a bit more down, there is an Unsloth Google Colab example. And so if you open that up, you will open up a Google Colab. And this, you can run this notebook directly for free. Inside of Google Colab. And so, for folks who don't have compute, this is a very good way to get started for the AgentBeats competition. And so like, this whole notebook shows you how to load up, Unsloth, how to, make an environment with OpenEnv. And so like, if you scroll down a bit further, we rendered the 2048 game board. And if you, scroll through, a bit more, how do we actually execute the strategy? Trying different types of strategies, how do we like add a time limit so like the model doesn't like, generate infinite strategies, right? We don't want like infinite loops. How do we do like code generation? How do we actually execute code? How do we like lock down the function so it doesn't actually like cheat or, do reward hacking? And so there's like many functions and, helper functions inside of this notebook. And if you keep scrolling down, the reward, when you actually do, making the reward functions, for example, if the model actually cheats, we reward it with -20, for example. And if it does not cheat, we reward it with +1. So all of these numbers, you get to decide on which, what are the numbers you like to use, right? It doesn't have to be -20. It could be like, -100, for example. And so we also check, for example, if the OpenEnv environment for 2048 actually succeeds, right? Did the strategy actually, win 2048? And if it did win, we just reward it +20. And if it failed, but the function kind of worked, we still reward it with +2. And if it, totally failed, we just do -3. And the trick of reinforcement learning is you only need one question, right? So like create a new short 2048 strategy using only native Python. You don't have to have like one question, but for this example, you only need one prompt. You can have like, many different other prompts, one to create Python functions, one to create, 2048 game. There's many options you can do, but in this example, we just use one prompt. And then, you configure, we'll be using HuggingFace's TRL, which is Unsloth is built on top of. And, there's many, parameters you might have to tune. We have a guide on this on our docs as well. But, like when you actually start the training run, you can actually see the automatic strategies that are being generated. And, over time, you have this like large table, and you just need to look at the reward column if it's increasing over time. And, you can actually see the generation and the plays of the actual algorithm. And so, that's one of the tricks of reinforcement learning. You just have to wait and see, is the reinforcement learning algorithm actually working? And if you see it's not really working or getting stuck, you might have to like edit the reward functions. You might have to edit the process. Yeah. But yeah, so definitely check out the OpenEnv, GitHub package. Check out Unsloth's GitHub package as well. Yeah, so like, thanks for my part. But so next up, we'll have Ben from HuggingFace to talk more about OpenEnv and HuggingFace.
Actually, I'll also let Ben answer this question, but there was one question asking who decides the reward. It's so right now we leave it open, and again, if you disagree, please complain on our GitHub repo. We leave it open for you to either have it packaged in the environment, so either the environment can decide, or you can decouple it from that logic as well. If you use AgentBeats, then of course the judge agent can decide this. But I'm curious to hear what Ben might have to think on this.
No, I don't necessarily have a response to that. There was one question in the YouTube that was quite interesting about how MCP relates to the Gym API, which I thought we should go into because, yeah, there's an option there to use the Gym API or MCP, and MCP seems to be the way that we're going. But really, that comes down to the use case, and there are definitely advantages to each, I think. Okay, I'll get started. So, as we've heard, OpenEnv is kind of based in two places, right? It's based in the GitHub repo, and that's where all the software is, and all the tutorials and the documentation. And it's also based here on the HuggingFace hub and the OpenEnv organization. And this is where all of the envs are in their like running and usable state, right? So this is where the envs are distributed. This is where they're deployed. And this is also where you will distribute and deploy your envs, and that's how you'll submit, right? So if you just take a look here on the hub, you'll see there's a README here that is in fact almost exactly the same as the GitHub one, just a bit more concise. It gives you the snippets there that you'll need. Down here, you'll see these collections. These are probably the most important place to come. You'll see a set of collections for different environments. Here's just a mixture of the latest ones, Environment Hub v 2.10. That just means that these environments align with that version of the software. All the others are kind of just like categorical, like we've got some real world agents here. So a calendar environment, a reasoning environment, web search environment. You might want to pull these in packs, or if you were using a multi-environment. And then we've got like reasoning games there, and they're just kind of categorized. Okay, so your objective will be to, as I said, to publish one of these envs, and that's what I'll show you first. And the other part will be to publish a blog post, and I'll also show you that. So everything I'm going to say is based on a tutorial, which is also in the GitHub repo. As we've heard before, OpenEnv, also meta/pytorch/OpenEnv, and just go to this tutorial directory. And what you have here is actually a kind of repetition of other information that's spread out, but it's a bit of a like one-stop shop where you can come and kind of go end to end and walk through the process. So it's a nice tutorial to go through. You'll see that there's a first page, environments. That is really a repetition of everything that Sanyan went into. And so we won't go into that now, but it's just in a markdown format. So you can just kind of read that. Works quite nicely on mobile, but it's probably not the best way to kind of build on top of it. You might want to go to the notebook to build on top of it. Then there's a deployment page. That's what I'm going to focus on. And then we've got another page on scaling. So this is, let's say you've got this env and you want to go to multiple GPUs or multiple devices. That will show you how to deploy those envs. I won't touch on that today, but it's pretty cool and it's worth reading. And then the fourth page is on training, and that uses TRL. And so you can go into that and get an example of training. And we've also got some example notebooks, the one that Sanyam showed, OpenEnv tutorial, a Wordle example in TRL, and the Unsloth example that Daniel has already shared. So that's like a one-stop shop that you can come to inside the OpenEnv repo. This is the page that I'm going to start with, and it's called Deploying an OpenEnv Environment. Okay, so as I said, all of the environments are on the hub, and they are on the hub as spaces. So you'll come and you'll find them all here just under spaces. So like with all the sort of computer vision and various other demos that people deploy as spaces, we'll also have environments here. Now, something that isn't fully known about spaces, actually internally and externally, is that they have three interfaces to them. They are at the same time a server, so you can access a URL of them and use the application running. They are a repository, a code repository, so you can pull and push and commit code to them. and they are a Docker registry. So you can pull that application as a container and use it as a container. So there aren't many other projects that take advantage of spaces in this way, but OpenEnv is one of them. So it kind of uses spaces like to the max, let's say. So if you come here on the hub, you'll see there's a button here, run locally, and it'll take a while to render. Maybe it won't render. Okay, I'll have to try another one, but first go back. Let me try this one. There we go. So what we have here is a Docker run command, and this gives you, in this case, for a certain platform, you'll need to change that, but it gives you a Docker tag that you can use to run this space, and you can run this space locally. You'll also see here, clone this repository, and it will give you a git clone command so you can pull the code. And up here in your browser, you've got the URL that you can use to interact with it like an API. So you have those 3 points, and that's shown here in the tutorial. So how do we run a server? An env? How do we use an env within our Python code? Okay, so the first example is to use it like a server, use it as a remote space. And so in OpenEnv, I can just instantiate the echoEnv class, and I can pass that URL to it, and then I can use it as Sanyam showed on that space. So I'm using the space infrastructure. Now we benchmarked this, and you can get up to reasonable batch sizes. So all of the tutorials that we've shown you in Unsloth and in TRL, they run with spaces on the free hardware. If you go up to kind of paid tier on Colab, you might then need to also pay for the Colab in order to keep up with that speed, but you're still talking in the cents. And you can go up to a reasonable batch size while still running completely on spaces, which is pretty cool because it means that you don't really have to think about Docker or anything else. That said, there's more to the end, right? There's the client code. So how do you get the client code that you're looking at right here, like all of this? How do you get this library? So for that, we take advantage of the space as a repository, and we say pip install git the space. And then we can install the client code and run the client code and interact with the server. So and the great advantage of this is that we've interacted with the same code, right? So we don't really need to worry about versioning as long as we're pointing at the same space. The final way would be to get the space would then be to use it as a Docker to pull the container and do Docker run and pass the URL. And then we can run the space locally. And in order to use that in OpenEnv, we would then need to pass the URL to that same class and say, okay, this time interact with a locally running container. Cool. So that's basically the quick way of getting to that same space from 3 different angles. Now, we've also got some convenience methods like fromEnv and fromHub. And in essence, they just do the same thing that I've shown you in broken up ways. So if you pass fromHub, then it will just pull that env as a Docker container and run it and then connect to it. And to go into those kind of details of your exact configuration, I just suggest that you explore the docs and take a look at that. We can also do some other things. We can also run the environment as Python code. If we say don't have access to Docker, then we can run it as a Python code. But first, I'm going to show you the project and how we create a project. So I'll switch over to the IDE. Zoom in a bit because it's always difficult. And so I'm just in an empty directory here. I've got a virtual environment, and I've installed OpenEnv from pip, like the stable version. And I'm just going to do OpenEnv init, and I'm going to say play, and I'm going to hit return. And the CLI walks you through scaffolding this environment. And so I'm going to change into that environment directory that's just created. But you'll see here that it's got some nice documentation that just comes out of the CLI, tells you where it's created this env, and tells you how to run it as a Docker container. Let's have a look at what it's created. So it's actually created a pretty big template for us. And if you go in, you see here, it's taken that name that I gave it, play. So it's created play underscore environment. I'll push this down for a sec. And you'll see that it's like cut in all the names of the ends that I want everywhere. And it's created this full template for us. And so in essence, it's given us all of the boilerplate. We just have to come in at this point here and start to add some business logic, right? Like what is the end going to be? What will it do? And really we can do that. And in fact, the env could be used as is. Like the scaffold could be used as an env. It would just give you zeros all the time. So you can really start with quite simple ends and building out this business logic in the reset step methods. So let's say it's a game, you'll know that the step will be the steps through the game, and the reset will be, let's go back to the beginning of the game, etc., etc. And you can use the scaffold to do that. It will also give you a Docker file, as Sanyan went in. Everything is based on Docker. In most cases, you won't really need to touch the Docker file. Unless you use something outside of Python, I'd say you can probably just leave the Docker file as it is. So if you're building a Python-only env, just move on. Likewise, there's a project toml, and you can use the project toml to install dependencies. You'll probably need to use that because you'll probably use some kind of dependencies. So this will be a first place that you come. And another thing that you should check is that you're using the right version of OpenEnv with the environment that you're using. You might want to install it from source. You might want to pin it. I definitely recommend pinning it, pinning the env when you deploy it, when you share it, because if you attach it to a GitHub repo, it probably won't remain stable. So you should definitely freeze it when you publish it. And that's the main way to do that. Right, so that's the code side of building an environment. The other element to take a look at, the other piece of code, I suppose, would be the client and the models. And they will need to correspond to the business logic of the environment that you set up. So here you'll see this is based on the echoem, so it's message and then the echoed message. For a game like Wordle, it would be like guess and then score, something like that. So you need to define the business logic here again in models and then in client to make sure it's used. So those are your two sort of like theaters of operation, let's say, models and play environment. Right, cool. Okay, so now let's publish the env. OpenEnv push, and I need to pass a repo ID. In fact, I don't need to pass a repo ID, but I'm going to, yeah. Cool. So that's now published that to the hub. As I said, I don't actually need to pass a repo ID. The OpenEnv CLI will just take the name that you've configured in here and use that as the repo name. So that's available, but if you want to specify where it's going to go on the hub, then you just pass that repo ID command. If you've used if you've used the HuggingFace CLI, then you'll find the OpenEnv CLI really familiar because it uses all the same parameter names and stuff. And this is that end that I created. It's just starting up now. Here's one that I created earlier while I was practicing, and it's there sort of ready to go. And it works as an echo env on the hub. Okay, so that's it. You've published an environment. The last thing is to post a blog post about it, and I'll just show you how to do that. That's super simple. You just go to your like your profile on the hub, and you click new here, and these are like all the new things that you can add on the hub. You just click article, and you have a markdown editor. You can write in markdown. You can preview it just like any other markdown editor. Feature that we added last week actually is that you can see all of the articles that you're drafting, which is pretty handy. I think something that's probably useful for this would be to note that you can set co-authors here, and that's just the other users. And when you do that, it will show up on the hub. Let me just show you. It will show up on the hub as your co-authors. Look, this is a great article here, just published by Daniel and I, just coincidentally. and it will render the names of the articles of the authors on the front here. So if you did the project like with other people and you want to credit them, then make sure you include their usernames and they'll be there shown as well with their avatars and everything, and it will link to their profiles. Other than that, it's pretty straightforward. You just populate the URL with whatever you want that's available. You can set a thumbnail, which is pretty good. Some people forget to do that. I definitely wouldn't, because it just looks way better on the landing page. If you have a look here, like this person forgot, and it kind of doesn't look as good. But these people remembered, and it looks a bit better. And that's it. Then once you're done, you just click publish. Okay, I think that's all from me, unless we want to go to some questions. If we collect some, I'll just go back through and give a little overview of everything I went through. Cool. So just to sum up, go ahead.
Oh no, I was gonna say we have about 7 minutes. We can take a few questions. But finish your thought, Ben.
Yeah, just ping them in when they're coming. So just to clarify, the directory of the tutorial is in OpenEnv. So the first place I would go after this call is to the OpenEnv GitHub repo, and I'd go to tutorial, and that will walk you through all of these examples. You can deploy an env by doing OpenEnv init, make it, and then doing OpenEnv push, and it will be on the hub. And once it's on the hub, you go and create a new article in your profile page. That's all.
My favorite comment in the chat is this sloth is saucy. Someone's asking, and their takeaway is defining the judge and the reward the main thing we need to focus on. I'll let Ben answer and maybe then I can chime in.
So in essence, you don't need a judge to have an environment, right? Like some of the environments that we saw, like the one that Daniel showed in the 2048 game, it doesn't have a judge. It just has a reward. So I'd say defining the reward is a necessity. You can define a judge. That's like a more advanced, like a more complex setup. I'd probably start off with just a reward-based RL problem and go up from there to incorporating judges.
Yeah, I will also add that a lot of your focus will be on like designing the environment. So you can imagine if you're like building a game like Pokemon, there's like a lot of complex behaviors which then you'll have to focus on. But I guess the question is also coming from the fact that this is in integration with AgentBeats. So if you're trying to build on top of the integration, then yes, you might spend some time thinking about how the judge sort of evaluates the actor agent. But only in that case. If you're defining the environment, then maybe you don't have to focus on just that, like Ben said.
There is a question. Do you have any presets for assigning token advantage in non-uniform ways? I think maybe the question's about like, how do we assign rewards differently for each generation or something? I think that's what they're trying to say. So I think during reinforcement learning, if there is a generation that's good, then you assign a good reward generally. You can also do negative. I guess you can reverse the process. And then if it's a bad answer, you should assign a negative reward. That's generally how reinforcement learning works. However, if you want to assign rewards to each step, like not just the final reward, but like, line 1 is like reward minus 100. Line 2 is minus 10. That's called process supervision. So you can do that. It's just much more computationally expensive. You might have to like call like another language model to like judge the output. You could do something like that. So you can assign rewards non-uniformly, but in general, to speed up the process, we just assign a reward at the very end. The other question is, how do you connect an environment with an RL training group? Yes, that's why you should use OpenEnv. So when you have OpenEnv as a training environment, so like you can create the training environments with OpenEnv, you can then use TRL, Unsloth, or like some other trainer to then utilize OpenEnv's environments directly. And so like there are integrations with TRL, Unsloth. So you definitely check out the free notebooks that we have, from TRL and Unsloth. And so they already directly integrate with OpenEnv. So that's kind of how you do it.
Daniel, when you say directly integrates, how many lines of code is that?
Oh yeah, okay. We did, quite a bit. So there are some, but for the
But no,
for
the user, I'm asking for the user.
for the RO practitioner, it's very short. So you just need to define, the RO environment. How do we, launch OpenEnv? So it's actually very easy. But the hard part is already, it's already done in terms of implementation. And so now you just need to focus on how do you make the environment, how do you design the reward functions, how do we, make the process much better. So like you don't need to focus on like implementation and stuff like that. Yeah.
I guess what I was trying to allude and what Ben is about to talk about is it's just like one line of change to go from one environment to another. And Daniel has written like a lot of code to make sure that works out of box.
Yeah, that's correct. Switching between environments is definitely just a hot swap. It's the building the environment that I think there's value in kind of getting stuck in. And that's why I think there's so many environments around like reasoning games and why people go straight there, because they're very like easy and logical ways to understand like the learning process. So for me, Wordle is like the first place to go from an educational point of view, because the game plays out over a certain period of time. There are many like trajectories that the model can go on, which are like quite naive, and the model quickly goes on to them. So you can see that kind of playing out. You have a different like two categories of guess in the game. Like you can guess something that is a correct letter and a correct letter in the same place. So when we implemented it in TRL, we actually explored different rewards for a yellow and a green letter, and then another reward for a complete game. We, for example, discovered that models love to just repeat the same letter. Like, okay, so I got a green for that letter, so it must be right. I'll just keep giving that guess again, something that a human would probably never do, but the model just kept doing it. So we created a reward that just penalized the model whenever they made the same guess again, so that it would learn that quite quickly. And some of this is trial and error for yourself of like building that reward and figuring out how the model learns. Yeah.
Yeah, like okay, on other questions. So yes, for token level and trajectory level, so I think that's the process supervision part. So like, if you do want to assign rewards to each line, like, not, each token specifically, and not like, the final reward, that's called process supervision. So definitely like, check process supervision out. It is supported in Unsloth and TRL and OpenEnv. It's just a bit more complicated. So definitely check that out. And yes, you do not need to use GPT-OSS. You do not need to use GPT-OSS for training and RL. You can use Llama, you can use Llama, you can use any open source model that you like. It's just, just an example. You can use, GPT-OSS. Yeah.
Yeah, I'd say the smallest model I've gone down to are the Quen 3.6b. But I would say that with Unsloth, like you can get bigger models into memory. And so it's definitely worth going there, because it does make the challenge slightly easier if the model is reasonably capable. These very, very small models can struggle with these reasoning games.
Yeah, like if you have like 48 GB of VRAM, you can do like Llama 70 billion. You can do like ginormous models as well. And so like there are many tricks that, the training libraries employ to like, reduce memory usage. But yeah, you don't need to use GPT-OSS. You can use any model for the competition.
Awesome. I think we're on top of the hour. So maybe I'll ask one closing question to like everyone. Maybe I'll also put Joe on the spot. What's one submission that you would like to see from the participants? And guys, you should know we are the judges, so maybe you should like listen to what we're about to say.
I mean, I'd personally love to see something. I mean, we have a lot of games. We have a lot of, reasoning kind of environment. I'd love to see something around math and science. Like, I think there's some really, really smart folks at obviously at Berkeley that are experts in different domains. So I would love to see a few submissions there, because I think those can really help generalize models, generalize your model in post training. That's my wish list.
Ben?
So we had a recent submission of calendar gym, and I'm really into that kind of category of submissions, like the real world. Like I could imagine like an email gym, like a social media post kind of env, like to get the maximum reactions or impressions. Like these kind of just like real world like envs that models are going to use every day in usage.
Awesome. Daniel?
No, I agree with both of them. Like, we need more sciencey, like less games are good. Like they're very easy to like get up to speed with what reinforcement learning does because it's very easy to like implement. It's very easy to like, see the reward trajectories, it's very good. But if someone can do more, more interesting examples not related to games, that'll be very, very that'll be very helpful. And I think this will be very beneficial for everyone as well. So for folks doing the competition, you can do games as like a, getting up to speed with reinforcement learning, but try to do non-game related submissions. That'll be very interesting.
Yeah, I've been on local Llama quite a while. I think it's like my most visited website probably. I saw a food truck or like a vending machine benchmark yesterday where you like kind of simulate a food truck business and like a vending machine where you have to like interact with customers and order like supplies. I think that fits into like the AgentBeats paradigm pretty well. So I'd like really
That's
love to
pretty
see.
cool. That's really cool. Yeah.
Awesome. I think we're on top of the hour. So I'll again thank everyone for joining. So thanks so much for your time, and also thanks to the Berkeley team for hosting us.
Yeah. Thank you so much. This was awesome.